So I'm Jeff Fudge. I started the AWS user group probably about 3 years ago. Appreciate everyone's attendance here. If you haven't already, if you want to introduce yourself on chat, that's great. We always like to know if someone is outside the state of Florida or sometimes in a different country. If you want to specify that, that's great also. I would say about 3 or 4 months ago, I was lucky to have IO Associates reach out to me. They have a UK office, but now have a Tampa, Florida office. So we're looking forward to getting some of them over here as soon as things calm down with COVID and travel bans and everything. But appreciate their sponsorship. They've helped us get a lot of high profile speakers. And at this point, I'll turn it over to IO Associates and Sam and Elliot.
Amazing. Well, yeah, thanks, Jeff. And thanks, Alex, for for supporting the group. Quick one from me. So for those of you that it's your first time on this user group, so yeah, Jeff's kindly let us get involved and help kind of grow and support the user group. We're a recruitment partner based out of Tampa. We just operate within the cloud technology space. If you're a candidate looking for new roles, more than happy to have a conversation, talk to you about some of the interesting positions we've got at the moment. There seems to be quite a lot going on, which is great news locally. And on the other side of the coin, if you're in a hiring capacity and you're looking for some great people, then feel free to reach out to us and we'll have a chat about the type of people we can help you secure. Without further ado, I'll hand you over to Alex DeBrie, who is an AWS data hero, and he'll be talking about using DynamoDB within serverless applications. Thanks very much. Over to you, Alex.
Great, thank you, Elliot.
I think if everyone can mute their mics whilst Alex is speaking, that'd be brilliant. And then, Alex, how would you like to do questions? Entirely up to you. Either you'd like to screen them as we go, or wait to the end.
I'm pretty flexible on questions. If people want to just butt in when they want to and say whatever they want, if you want to type it in chat, I think I can monitor that a little bit as well. Actually, if someone would just let me know if there are any questions in chat and speak up. But yeah, I'd say don't be shy. Feel free to ask questions. I'm here to talk about Dynamo. So
take it away. Nice one.
Cool. Sounds good. Let's do it. So if you've been working with AWS in the cloud in the last couple of years, you've probably seen a lot about serverless applications, right? And the big thing around that was AWS Lambda, which is now 6 years old, I believe, at reInvent this year. So 6 years ago, Lambda comes out, right? And it's this new sort of way to build applications, to build compute. You have this compute in the cloud. It's event driven. It's ephemeral. It spins up. You pay per use. Pretty interesting stuff there. But really, this code is only useful insofar as you can trigger it when you want to do something. So you often see these different event sources like Amazon API Gateway, right? You can hook up HTTP requests to your Lambda functions, and now you can run basically like little web servers, right, in your Lambda function, or respond to HTTP requests. But even that, by itself, API Gateway, Lambda, not enough, because usually you need to do something with that request coming in, do something stateful with it. And it might be, using a service like S3 and saving some data to S3 that way. It might be writing a message to SQS and queuing something up to do some downstream processing. Or it could be any other type of sort of, eventing type service like EventBridge, Kinesis, simple notification service, anything like that. But probably most commonly, you're going to write it to a database, right? And that's just a pretty common way to have these HTTP applications. And within databases, you have a lot of different choices. You can go relational, use something like Amazon RDS. You can go DocumentDB if you want to use something like Mongo. But we've really seen a lot of people use DynamoDB over the last 5 or 6 years with Lambda in these serverless applications. And that's sort of what this is talking about, right? Why are people choosing to use DynamoDB in their serverless applications? What makes it fit so well? And then, because Dynamo is so different than maybe a relational database that you used in the past, we'll talk about some data modeling principles and some tips as you get started implementing it. So that's what we'll talk about today. Again, 3 big topics we're going to talk about here. First of all, why DynamoDB and serverless? Why are people choosing to use DynamoDB and making it the database of choice in their serverless applications? Second, we'll do basics of DynamoDB data modeling. And then finally, we'll just talk about some tips for successful implementations as you're doing your data modeling. So who am I? I'm Alex DeBrie. I wrote the DynamoDB book, which is just a comprehensive guide to data modeling with DynamoDB. So you can go check that out. I also wrote DynamoDBguide.com a couple of years ago, and that's just like a friendly, easy introduction to the Dynamo API, the SDK, what that sort of looks like. I'm an AWS data hero due to my work with Dynamo, and then during my day job, I'm an engineer at Steady. Just a little bit more about the DynamoDB book. Yeah, it's a comprehensive guide to data modeling with DynamoDB. It's 450 pages plus a bunch of extras. It talks about relationships, sorting, filtering, uniqueness, all sorts of stuff. And then it has 5 full walkthrough examples and pretty in-depth stuff, not just basic stuff. So like one of the examples, we walk through modeling GitHub, and we do users and organizations and repos and pull requests and issues and everything you want to do there. So if you want to check out that book, that's at dynamodbbook.com. Feel free to hit me up if you have any questions as well.
Maybe our sponsors, IO Associates, could purchase a couple copies, and we can raffle those off.
There we go. Hit me up. I would love to do that. Jeff, I'm gonna have to put you on the payroll here, right? Marketing director.
I'll be your marketing rep.
Yeah. Cool. So let's get in here. Let's do why DynamoDB and serverless. Why are so many people choosing to use DynamoDB with Lambda and sort of other serverless components? And there are a number of reasons why. First one, I think that really gets started is just the interaction mechanics. How you use DynamoDB feels very similar to how you use a lot of different other AWS services. And really in these serverless applications, you're often just gluing together these managed services, whether that's SQS or Kinesis or SNS or EventBridge or any of that stuff, S3. It feels very similar using those versus DynamoDB. So let's just do a quick example here, right? If you're going to use something like SQS, right, as a queue, this is what it might look like in Python. First, you'll import your library. So here it's Boto3 if you're using Python, but it could be sort of whatever fits for your language. Then you're going to create and initialize a client for that particular service you want to use. And then you're going to call the method on that particular service. So in this one, we're going to send a message. We're going to enqueue a message to SQS. Likewise, let's look at S3, same exact format here, right? You're going to import that library, you're going to create the S3 client, and then you're going to call some method on it. Here we're deleting a particular S3 object, but it could be put object, it could be copy object, whatever. And really that's the exact same with DynamoDB. So here's DynamoDB. It's going to look the exact same as using SQS S3. So if you're familiar with AWS, it's going to feel very familiar to use DynamoDB, right? You're going to import that library, create the client, and call the method. And this will be a little different than using a relational database where you have to you add this library, but maybe you set up a connection pool. You have to do all this sort of pooling stuff and just different mechanics. You're passing into these like text strings into your database. So it's just a little different in terms of the mechanics of how you use one versus the other. So I think people like that, right? You get that managed service feel and the same mechanics there. Second reason after interaction mechanics is just the permission model. Again, very similar, the permissions model on DynamoDB as compared to other AWS services. So here's an example. This is from serverless.yaml if you're using the serverless framework but anything like that. But if you're setting up IAM role statements on your Lambda functions to give them permission to access different things, you might have something like this at the top that says, hey, give permission to send a message to my SQS queue, and you have this effect action resource layout that you have here for your IAM role statements. If you're working with DynamoDB, it's going to be very similar, right? You're going to have effect action resource. You're going to say, hey, you can do get item, you can do put item, you can do query, you can do it on my table. So it's a very similar mechanics there, rather than having to go learn that sort of user model within Postgres or MySQL, where you have a different disjoint model and you can't sort of provision it here. So I think just, again, having that consistency across services is nice. Also, the permissions model really works well with Lambda, right? So if you're working with, EC2 instances or Lambda functions, right, they're going to be, if you attach a role to those AWS compute, they'll inject temporary credentials into that Lambda function for you, and those are automatically discovered by that AWS SDK. So you don't have to worry about, secret management like you might with a relational database where you're sort of storing these usernames and passwords somewhere. You have to rotate those yourself. If you're using, if you're relying on AWS IAM for your permissions here with DynamoDB, you don't have to worry about that, which is another nice thing. So that's the permissions model. Let's get into the provisioning model as well. How do I set up DynamoDB and use it? And again, it's going to be very similar to setting up other AWS services. So here's a little more CloudFormation here. I might be setting up an SQS queue, right? And I have to give it a logical ID. I have to specify the type, give it its properties, and then same mechanics you have with DynamoDB. So you can provision that all very easily. And again, contrast that with a relational database. you can provision a relational database using CloudFormation and do that that sort of infrastructure provisioning, but you still need to do some prep work in that relational database to set up your tables, set up your indexes, set up your users, different things like that. That doesn't really fit cleanly into an infrastructure as code world, which you're probably using if you're in this serverless world. So again, provisioning fits really well into that serverless world, just like your other managed services. So then you have that provisioning model. Next one is the billing model. And I think this is a real game changer for how people think about databases, right? You don't have to do this sort of instance-based, always-on pricing. So there are two billing models for DynamoDB. There's provision capacity and pay-per-use. So provision capacity, you say up front, I want this many read units, I want this many write units per hour, and they're going to charge you a fixed fee on that, just like you would if you were, you had an EC2 instance or an RDS database, something like that, where you have some RAM and CPU. But you can also do pay-per-use, where you say, I don't want to do any sort of capacity planning up front. I don't want to do any pre-provisioning. You just pay me for the reads and writes that I actually make against my database. And it's going to be, a quarter per million reads and a $1.25 per million writes or something like that. So it's pretty cheap still, but you get that pay-per-use. You don't have to do capacity planning. Really great, especially if you don't know your usage patterns. You don't have to worry about sort of running out of capacity, but you also don't have to worry about, vastly over-provisioning. The other thing I like about the billing model, and this was true even before that pay-per-use, is you're paying for reads and writes directly rather than resources, right? So if you're using a relational database and you have to do capacity planning, it can be pretty difficult to do that, because not only is it hard to know, how many users or requests or all that am I going to have during this time, that's a guess, but then turning that into, CPU and RAM and what does that mean for disk space, all that stuff, that's a little bit of a guessing game, right? So that's hard to do as part of that capacity planning. With DynamoDB, you're sort of charged, whether that's provision capacity or pay-per-use, based on your read and write units, right? So if you read 4 kilobytes of data from DynamoDB, it's going to count as one read unit, right? And if you're going to write 1 kilobyte of data, it's going to count as 1 write unit. So if you know, or if you can estimate in some bands about how much traffic you're going to have and how big those requests are going to be, it's going to be a lot easier for you to plan that out than in a traditional like CPU RAM-based model. So that's the billing model. The last thing I want to talk about is just the scaling characteristics. And I think this is what really turned up people on to DynamoDB at the beginning as compared to relational databases. And just, if you have this ephemeral compute model like Lambda, where you can have all these different functions spinning up all over the place, that can overwhelm some resources that sort of weren't built for this more ephemeral hyperscaling world. And relational databases are kind of like that. A lot of relational databases have connection limits where you can't exceed 100 or 150 or 200 connection limits based on how many you've configured there. And that works great when you have, more permanent persistent compute where you spin it up, you create a connection pool, and that's sort of reused across a lot of app instances on a particular instance. But when you have this compute spinning up all over the place, you can have thousands of Lambda functions running at any given time, and it's hard to manage those connection limits. So DynamoDB is going to handle that a lot cleaner. You don't have connection limits to worry about, and really all you have to worry about is, have I provisioned enough, or am I using pay-per-use and get as much as I want? So scaling characteristics, last reason people really choosing Dynamo, especially at the beginning.
Hey, Alex, just going quickly back to the billing model, unless you're going to cover this later, but can you give us a feel for, and I know the answer always is it depends, but can you give us a feel for the cost of using, let's say, a relational database with serverless versus DynamoDB? Is that a 2x, 5x delta? How big is that gap?
It's really tough to say. The one thing I would say is, most serverless applications I've worked on or talked with customers about, it's amazing how small of a percentage DynamoDB and Lambda end up being as a percentage of their total bill. I tell people, I often see people's bills, especially if they're building, web APIs where they have API gateway, Lambda, and DynamoDB. If that's their sort of stack, it's pretty often where I see 40% of that go to API gateway, which is just crazy. 25-30% go to CloudWatch logs. Maybe 15-20% go to Lambda, and then 10% go to Dynamo, or maybe flip that with Dynamo and Lambda at the bottom there, which I just think is nuts. If you think back 10 years and you said, hey, you're going to have this infinitely scalable on-demand compute, you're going to have this infinitely scalable, consistent performance database that can scale up as much as you want, and you pay per use. And then you're going to have basically Nginx, right? A proxy API gateway. And somehow that proxy, Nginx, that's been there forever, that's going to be the most expensive part of it. And it just drives me bonkers. And they've made some progress with the new HTTP API that's come out. So that's sort of helped. But I mean, I would say it's usually not a big enough problem to matter for a lot of people, depending on sort of how big that is. The other thing I would say that's really nice is like, both my current job and my last job, you know, we would have our production environment, a staging environment, and then as developers, we could spin up our own stacks as we wanted to, if we wanted to test out our code, do things like that. With Dynamo, you can spin up a stack, you make it pay per use. If I run some tests, it's going to cost me, you know, fractions of a penny to run that test. Whereas if I had to spin up a whole relational database, just even the smallest size of that or keeping it running is going to cost me some amount each month. So it's really nice for that sort of flexibility as well. Yep.
Thanks.
Yeah. Any other questions on these sort of things? This is the end of this section. I'll go on to another one. Sweet. So let's talk about basics of data modeling. This is just going to set the foundation, sort of terminology wise, vocab, just get us all on the same page there. So 4 key terms I like to talk about when I'm talking about data modeling with DynamoDB. That's going to be table, item, primary key, and attributes. I'm going to go through this with an example. So we'll have let's see, a session store here where imagine, you know, you have some sort of authentication, people log in, you generate a session ID and save it and then give it back to them, and they sort of return that session token every time you check in the database. If you see here, I have 4 records in my session store. If you look at all my records together as a whole, that's going to be called a table. So it's similar in some ways to a table in a relational database, but also different in other ways. We'll sort of see that as we go. If you look at an individual record in that table, that's going to be called an item. So you see I've outlined in red here this item for Black Widow. That's an individual item, you know, representing that session token, but also some data that comes along with it. Now, when you're creating a table in DynamoDB, you need to specify what's called a primary key, and every item you put in that table needs to have that primary key and needs to uniquely identify that item in your table. So you can't have 2 items with the same primary key. In this example, we've got the primary key there. Over on the left, it's the session ID, right? That's going to uniquely identify each item. That's going to identify who's logging in our application. Now, in addition to that primary key, you can also have other attributes. So we have those over here on the right, username, created at, expires at. These would be similar to columns in a relational database, with the big difference being you don't need to specify these up front like you would in a relational database. So, you know, relational database, you have to say, here's the column name, here's the type, you know, default value, required, all that sort of stuff. You're not going to do that in DynamoDB. Because of that, you might hear people call DynamoDB schemaless, and that's true in the sense that DynamoDB itself is not going to enforce your data model. It's not going to reject it and say, hey, it doesn't conform to the schema outside of that primary key. But if you're using a NoSQL database like DynamoDB, you want to make sure you have a schema. It should just be enforced sort of at your application layer rather than at your database layer. Any questions on that basic vocab? And then we'll talk a little bit more about primary keys. Sweet. Okay, so let's talk a little bit more about primary keys, which I mentioned before. Primary key is going to be super important in how you actually implement your data model. We'll talk a little bit more about that. But before we do, I just want to dive a little deeper here. There are 2 types of primary key: simple primary key and composite primary key. Simple primary key is going to be made up of just a partition key, a single element, where a composite primary key is going to have 2 elements, a partition key and a sort key. So that example we saw already, that session store, that was an example of a simple primary key, right? The primary key was just that one element, that session ID. If you want to look at a composite primary key, let's look at this. So here's a table that has actors and actresses and different movie roles that they've played over time. So we've got Tom Hanks, we've got Tim Allen, we've got Natalie Portman, a couple different movies in here. This is using a composite primary key with 2 elements, right? That partition key is its actor, and that's going to be the actor name. And then movie is the sort key, which is going to be the movie name. A couple of things I want to point out here is, you know, I mentioned that the primary key needs to uniquely identify each item. It's the combination of those 2 elements, if you're using a composite primary key, that uniquely identify it. So even though I have multiple records here that have Tom Hanks as the actor, or multiple records that have Toy Story as the movie, you know, it's the combination of those 2 that ensures uniqueness. And I don't have 2 with the same actor and movie name there. If you're working with DynamoDB and you're doing more complex applications, you're almost always going to use this composite primary key. That simple primary key, you can basically only do key value access on it, which can be useful for a lot of things. But if you're designing a bigger one where you want to have relationships or fetch multiple records in a single request, then you're going to need to use that composite primary key. So then I like to talk about, I guess before we get into the data modeling, I like to give you a little sense of like sort of what DynamoDB is trying to do. And one thing I talk about is what I call DynamoDB's guiding principle, which they don't advertise directly, but I think it really informs how they think about product decisions and things like that. And that's basically DynamoDB does not want to allow any operations that won't scale. What they're trying to do is making sure you get the same exact performance at a gigabyte or 10 gigabytes as you would at a terabyte or 10 terabytes or more, right? So this was designed for basically Amazon.com retail internally, and then rolled out and made a service for other folks. But really the original use cases were around those high scale applications where you're saying, if I'm getting up to terabytes and terabytes, how can I make sure my database isn't just going to lock up on Prime Day or something like that? So they really want to make sure your database that you can't do something at 10 gigs that's not going to work later on down the road. And because that, you need to know about sort of two design decisions they made. And number one, the importance of primary keys in your data model, right? So going back to that composite primary key example with the actor roles in the movies, your primary key is very important, and you're going to do almost all your querying with that primary key. So it's very easy for me to go to this table and look up, Natalie Portman and Black Swan, pull that back, or pull up all the movies by Tom Hanks. But it's very difficult for me to query based on like the year or something like that, right? You don't query with those attributes. You're only going to query with that primary key primarily. Second thing about DynamoDB that throws people is there's no join operation, which can be really weird if you're used to having your relational database joins, and that really throws people. I think it's worth talking about why you don't have joins in DynamoDB. So let's talk about how DynamoDB works. I think of it as I used to think of it as just one sort of giant machine in the cloud somewhere, but that's actually not what's happening. What's happening is DynamoDB is going to split your data across all these different partitions, multiple different partitions, right? So about every 10 gigs of data you get, they're going to create a new storage partition for you and sort of split up your data that way. So imagine I have a table that had 15, 20 gigs of data. I'd have these two partitions in it. And these partitions, they aren't exposed to you. You don't actually need to know about them, but it's just, I think it helps to build that mental model. So I've got these two partitions. Now imagine I'm making a write request to Dynamo, and I'm saying, hey, let's insert this item. I'm going to use a put item request. I'm going to put Tom Hanks in the movie Big into my movie roles table, right? So what happens is that DynamoDB, it's called the request router, that front end, it's going to take that record, and the first thing it's going to do is it's going to hash that actor value, because that actor is the partition key that we've declared. So whatever your partition key, it's going to hash that and figure out which partition it belongs to. So in this case, it's going to hash Tom Hanks and figure out, hey, this belongs to partition 1. I'm going to reach out to partition 1 and write that record and return. And now the great thing is, if I add a third node here, that's fine. That first operation we do there, that's a constant time operation, right? Because it's hashing and it's doing a lookup and a hash map, basically, which is a constant time operation. So whether you have 2 or 3 partitions, or you have 100 or 300 or 3,000, it's going to be a very efficient operation, right? If you have 3 terabytes of data, this request is going to come in, and right away it's going to do that O1 operation to get to the right storage node where you're working with now 10 gigs of data, which is a very manageable amount of data for them to do. And that's how they can get that constant time operation. And that's why that primary key and no joins are so important. So given that, sort of what are the implications for our data model, right? They sort of put these two constraints on us. Primary key is very important, no join operation. What are the implications for our data model? And there are 3 big ones. Number 1, know your access patterns in advance, right? So this might be different from a relational database. In a relational database, you might sort of model your data more abstractly and say, hey, I have these different objects. Each object goes in a different table, and I tie the relationships between them via foreign keys or maybe a joining table. And then I say, how do I wrap my queries to handle my access patterns? With Dynamo, before you design your table at all and start putting data into your table, you're going to think about your access patterns first, list those out, and then design your table to actually handle those access patterns. Second implication is you might put all items in a single table, and this is what's called single table design in DynamoDB. This really throws people for a loop. We're going to look at this in just a second and see why it does this. But really, that no join operation, that's really what's driving this, right? If you want to get sort of multiple different items in a single request, you need to do this and sort of pre-join your data in different ways. Last implication is especially if you're doing the single table design, is you'll have generic attributes for your primary key. And those last two, this is part of single table design that you might have heard of with Dynamo. It really throws people. So I want to walk through an example of what that looks like. So let's do an example here. Imagine we're building a SaaS application. And we have two entities in our SaaS applications, right? We have organizations, and that's who's going to sign up for our SaaS application and use it. And then we have users that belong to a specific organization and will act on behalf of a specific organization to use that application. So let's write a few items to our table. Let's start off with a couple organization items. I've got two organization items written in this table, Berkshire Hathaway and Facebook. A couple things I want to point out here. Number one, look at that primary key, right? Again, I talked about using generic names and values for your primary key, and that's what I've done here. The partition key is just named PK, and the sort key is just named SK. It's not organization name or anything like that. And the reason for that is if I'm going to have multiple different types of entities in this table, they're not going to have the same values, right? So you can't use organization name because I'm going to have users that don't have an organization name, or you can't have username because you're going to have organizations that don't have a username. So I'm going to use these generic names and values for that primary key, which is going to help for most of my query patterns. Second thing I want to point out, if you look at the actual values for some of those items, you can see they're kind of a funky style there. Notice they have like a common template. So for every organization item, we're going to have a template for these primary keys of what it's going to look like. And that pattern is going to be org hash and then the organization name, org hash organization name for both the partition key and the sort key. That's just helping identify what type of item we're working with. It's also going to help with some of the grouping and different things like that as we go. So those are the two organization items. Let's add a few user items to my table. So now we still have those organization items here, but we've added these user items outlined in red. So in that Berkshire organization, we have Charlie Munger, we have Warren Buffett, and then in that Facebook, we have Sheryl Sandberg as well. A couple things I want to call out here. Number one, if you look at those user items, notice that the sort key there has a different pattern, right? We're not using that org hash pattern again. Now we're using user hash and then the username. So it's a different pattern for these different types of items, and that's going to be part of our data modeling. Also, if you look at the attributes you have there, notice how the organizations, right? They have attributes that matter for them. So there's organization name, there's subscription level, stuff that matters to that organization. Whereas on that user, they have attributes that matter to them. They have username, they have role. So that's where that schemaless nature of Dynamo comes in, to where you can, have different attributes for your different entity types in a table. Take a quick break here. How are we doing on single table? Then I'm going to move into some tips and different things like that. Any questions on where we are so far, or the partitioning stuff, or any of that stuff?
The only question I guess I would ask is, as you've seen, let's say, relational database individuals move to a NoSQL paradigm, has that been an easy transition, or maybe just talk about the typical conversion over?
Yeah, I think the hardest part is really understand that you're working with a different database. I think where people get into trouble is they try to take their exact same data model in a relational database and implement it in Dynamo. And they think, hey, Dynamo has tables, my relational database has tables, I can do that. The problem, you'll get into a few problems there, especially using, all these different tables, and you'll have, Dynamo doesn't have joins. So what you'll often end up doing is implementing joins in your application code, where you'll be hopping all over. You'll be fetching a couple records from this table. Then you'll be like, okay, now I have to go fetch a bunch of records from this table, join them together, then fetch records from this table. And you end up just having this sequential waterfall of requests. And I think that's where people get into trouble. A few other things, another place I see people get hung up is they're used to having like a primary key or an identifier being like an auto incrementing index. Difficult to do with Dynamo, so see if you can use something more meaningful, such as a username or an organization name, or if it's something you're creating like an order or some other type of record, use just like a UUID or different unique identifiers that you can put in a URL path or something like that that will help identify your items. So I'd say the biggest thing is just make sure you understand and take some time to understand the principles of Dynamo, and maybe start with something smaller, because it's gonna be hard that first time. But you know, once you've done it once or twice, I think you're like, okay, I understand this, and it's actually pretty straightforward. And the big thing that I like is you completely understand the scaling patterns altogether, where it's like with a relational database, I'm like implementing some stuff and I'm just like, I have no idea how some of this is gonna work or not work as it goes. You know, if I'm doing big aggregations and sums and counts or something like that, what's gonna happen? If I'm doing monster joins, like what's that gonna look like? With Dynamo, you can know pretty well with confidence what that's gonna look like.
Alex, you mentioned, this is Johnny.
Yeah.
You mentioned knowing your access patterns in advance.
Mm-hmm.
Are there some best practices around eliciting that information?
Yeah, that's a great question. So I would say it sort of depends on what you're doing. So most, just like my background is mostly doing like sort of web applications, web APIs. So the way I sort of think about doing that is like, hey, what are the REST endpoints I need to implement, right? And that makes it really easy. If you're building a web application and you have these 15, 20 REST endpoints, I have get user, I have create user, I have delete user, like now you're listing them all for you, which is really nice. If you're doing something else where maybe you're not building something RESTful or something like that, then it gets a little harder. But you know, I would say it really helps to know your application. So work through that and think about, hey, what am I going to do? What are the different flows I'm going to have? What are the different access patterns I'm going to have? And I'm saying like know your access patterns, and I don't mean like sort of think about it generically. I mean actually like write these down and list them out. And then as you're designing your table, being like, hey, this is how I'm going to handle this one. This is how I'm going to handle this one. And I think that's going to help you a lot there.
Awesome, thanks.
Yeah, good question. I would say like a follow-up to that one too, which I thought you were going to ask because I get it all the time. Yours is actually a better question. But I always get asked like, what if I need new access patterns? What if I have to change them? And I think that worries people. It's not that you can't sort of add new access patterns down the road. I'd say like a lot of access patterns, if they're brand new access patterns, going to be completely easy to add. Even if you need to sort of like, you know, add new access patterns on existing data, there's a pretty straightforward way of how to handle that, a mechanical way to do that. So you can add additional access patterns down the road if you need to.
Sounds good, thanks.
Yep.
I've got a kind of a detailed question also related to access patterns and kind of specifically what we're seeing on screen here. So I've seen, I think, 2 patterns in single table design. One of them is where you have the PK and SK set up like this, where you have org Berkshire and org Berkshire matching PK and SK, where you're going to store the actual profile data for that record for that item. But I've also seen people do things like org Berkshire and then just A or something like metadata as the SK. I'm wondering if you have any examples offhand of access patterns that sort of drove that decision in one way or the other. I couldn't think of any really where I couldn't think of any scenarios where I'd want to set up like a GSI where I'm partitioning all the A records in one place so I can query them. But yeah, wondering if you've seen that in any real world applications.
Yep, that's a good question. I would say it mostly doesn't matter, assuming something else, which I'll get to in a sec. But I used to do like sort of the org Berkshire and then metadata and something like that. And in fact, like a few of my past talks, you can probably see that. And in a broad sense, it generally doesn't matter. The one sense you're talking about is sort of like, what if I want to reuse one of those values in a GSI somewhere else? Like, what if I want to reuse a sort key value as like the GSI1 PK or a global secondary index primary key or sort key, which for other people's context, if you don't know, secondary index is basically a way to add another primary key to your table. What you can do is like declare the secondary index with this new primary key. Dynamo is going to copy your data that you put into this table into that primary key where you can read against that. So it enables additional access patterns on your data. So then, sorry, what's your name again? Was it Alex?
Alex, yeah.
Yep. Okay. Alex had a question like, you know, what if you want to reuse one of those values? And I sort of used to do that. I generally recommend, and actually that's going to be one of my tips I mentioned in the next section, is like, don't reuse sort of a one primary key value in another secondary index, just because it's hard to make sure that works across all these different entity types, and it gives you less flexibility if you want to add additional ones down the road or different things like that. I just found it's generally worth the storage cost to just like duplicate that attribute if you need to, rather than sort of trying to shoehorn that all together.
Cool, thanks.
Does that make sense?
Yeah.
Cool. Any other questions? And then we'll get into some tips and things. Cool. So this section is about tips, and it kind of like jumps a step. You know, I think we just did some basics, and then now we're getting into tips of successful implementations. There might be a little bit of context missing, so feel free to like ask questions if you can. I'll try and fill in as best I can, but some of this is going to be more intermediary to advanced stuff. So let's just walk through a few tips. One tip I have is I like to separate your item into what I call indexing attributes and application attributes, and basically just keep those separate. So if we go back to that SaaS application example that we just had, you know, I would think about sort of your primary key attributes, your PK, your SK, separately from your application attributes, right? And even though you see some of those values duplicated, right, the sort key, the organization name is, I actually duplicate that into your application attributes rather than sort of parsing that out at read time. So what I would say is, your application attributes, those are all the attributes you actually have in your in your application to be useful. Like, what's the actual data you want to store on your application? The indexing attributes, those are only used in DynamoDB to sort of arrange your data in a specific way, to index it in a particular way to handle your access patterns. So keep a nice separation between those, so you're not sort of overlapping. It's going to cost you a little bit more in storage cost. I think it's worth it unless you're really storing a huge amount of items and need to be very cost conscious. So indexing attributes versus application attributes. This also goes for secondary indexes, right? So if you have a secondary index, you might have something like a GSI1 PK, GSI1 SK. Again, keep those separate from your application attributes. Even if you have that value in your GSI, make sure you're also having it in your application attributes. So that's the first tip. The second tip I would say is sort of related to this, and make sure and just like within your application, implement that data model part at the boundary. So here's a little example I have. This is like a JavaScript class that's pretty bare bones in basics, but a few things I would say is like, this is like a customer class, right? And I'm going to have a constructor that has my application attributes, and that's going to be meaningful in my application, right? And I'm going to construct this customer and do that. And then I have a method in there, a key, right? That's how I build my primary key method. And then I also have this toItem method that's going to serialize that item to DynamoDB, and it's going to use that key method to add those attributes. So basically, when I'm saving to Dynamo, when I'm reading back from Dynamo, that's the only time I use the indexing attributes. They're all in the boundary of my class, and I don't really think about it within my application as a whole. Within my application, I'm actually using those application attributes, which are more meaningful to me.
Alex, sorry to interrupt. We had a question on the chat. So Andrew McCulloch's in the UK, so he's got to be respectful of his household and not wake them up. But
Sure.
He's asked, can you modify / update values that are used as primary keys in a GSI?
That's a great question. Yes. So in a GSI, you can update those values if you want, and then DynamoDB is going to do the work to sort of update your secondary index for you. You cannot update the values for your primary keys. So you can't say like update item on your primary key and say change the PK from this to that. And the reason for that is, you know, the primary key uniquely identifies that item. So if you're changing the primary key, you're changing that item. It's a totally different item at that point. So if you want to change your primary key, what you need to do is delete your item and then do a put on a new one that has all those attributes, which becomes kind of a hassle. So I recommend try to have your primary key be something that's going to be pretty consistent and not going to be changing. If you do have something that's going to have some changing attributes, then you put that in your GSI if you can, and then it's a lot easier. Dynamo, when they're doing that replication of that secondary index, they'll handle that delete and put operation for you. Yeah, cool, good question. I can pop over this chat too. Cool. Thanks, Andrew. Good question. So data model at the boundary. Next one, and we already talked about this a little bit with Alex, but don't reuse indexing attributes, right? If you're going to use, if you're doing your data modeling and you find out, hey, the PK for my table is the exact same as the GSI1 SK for a bunch of my items, maybe I can just reuse that and create a secondary index that uses that PK as the GSI1 or as the sort key in my secondary index. you might be tempted to do that. I tried to do that. You know, I think about like a puzzle and like what's the fewest number of attributes I could possibly write across all these things. And it just turns into a headache, I think, and really reduces your flexibility in a way that you don't want. So I would say, don't get cute. Don't reuse those indexing attributes. You know, if you add a secondary index, just create 2 new attributes for that secondary index and use those as you want them. And then you're not going to get into trouble down the road. Next thing I would say is throw a type attribute on all your different items, right? If you're going to have a bunch of different items in a table, you know, multiple different attributes, it's helpful to have that type item. Not only, you know, if you're browsing in the DynamoDB console, it's easy to see like, oh, this is an organization rather than having to parse the primary key and sort key. But also if you're doing, you know, when you're reading that back, you can check that type and make sure you get the right type of item. Also, if you're doing like, sometimes you might want to do like a big ETL process where you're maybe decorating existing items with new values. Maybe you want to index those in some way. It's really easy if you can do a scan and say, hey, scan where type equals user, and then add these items if it's a user, otherwise just skip it over. So use that type attribute. It's going to be your friend, even if you don't use it in your application. And then another one I have is write scripts to help debug access patterns, right? And if you have all these different access patterns in your application, you've written them down, all these different things like that. Sometimes it can be hard to like go replicate that in the console, right? If you need to like sort of assemble this really weird PK and maybe have these weird sort key conditions. And if you're doing that in the DynamoDB console, it's not going to be super friendly for you. So what I would recommend is have some scripts locally where you can run a script that says, you know, get user and user orders, and it's gonna take in a user and it's gonna return exactly what your application would return there. And the reason, again, this is gonna be helpful is if you go back and look at this table, we didn't talk about this, but all the items that have the same primary key, that's going to be called an item collection. It's very efficient to get an item collection. You can use what's called the query operation. And because of how that partitioning works in those different storage partitions, you can easily get this item collection. And you can see I can store different types of entities in a single item collection. So I might have an access pattern here in my SaaS application that says get all the users for an organization. And I also want to scoop up that organization item when I'm doing that so I can sort of, you know, enrich my users with information about their parent organization, just like you do with a join in a relational database, right? So what I've done here is I've pre-joined my data. But if I want to go assemble this in the DynamoDB console, it can be sort of hard to do that. So I'd recommend having those scripts locally where you can just say, hey, this is what my access pattern would be, bam, and it'll spit out those items for you and show you what you would get. You can have your different conditions and all sorts of things like that. So just help yourself out by writing those scripts rather than trying to do that in the console. And then last thing I would say, learn the strategies, right? Modeling with Dynamo is different than modeling in a relational database. I walk through a bunch of these different strategies in the book. So like there are 5 different strategies for one-to-many relationships. Some of them around denormalization. Some use sort of that composite primary key that we just saw where I'm co-locating multiple types of entities in a single item collection and doing different things like that. 4 different strategies for one-to-many or for many-to-many relationships. Lots of different things to do there. Filtering, sorting, migrations, all this stuff. Like it's going to be different working with DynamoDB, and it's helpful to know these strategies and sort of look at like a toolbox, right? And then you say, I have this problem. What are the different strategies I can have to handle this problem? So that's the strategies. Summary of what we talked about. You know, first we started off like why DynamoDB and serverless. A lot of people getting into serverless, loving Lambda, all the things it gives them. Why are we seeing DynamoDB really take off in this serverless world? And we talked about how similar it is to these other managed services, some of those mechanics, the provisioning, the pricing, the billing model, all this stuff makes it so DynamoDB is really popular. Then we talked about basics of DynamoDB data modeling, got some of that vocabulary in there, key concepts, and understood why Dynamo is the way it is and what are the implications for your data modeling. And then finally just closed out with some tips on successful implementations. Yeah, I'll be around for questions if anybody has any more questions.
Yeah, so the book has got a lot more information to go over patterns for how you should store your data in Dynamo versus relational, so that you can get your head around the differences when you're developing an app, right? To be able to properly do that.
Yep.
You get into dynamic, what is it, data migration service, anything like that relative to DynamoDB?
Database migration. So you're going from like a relational database and you want to put it all into Dynamo or something like that?
Something like that, yeah. You get into
No, I haven't done that in the book. Although I did just work with AWS to do some database migration courses and things like that. So you can go check those out. But and one of them does go from like a relational database into DynamoDB and talk about how you can even migrate a single table design if you want to.
Yeah, are you using DMS, the data migration?
Yeah, it was using DMS. Yep.
Okay.
So it's a little tricky. I mean, it's not super tricky, but I mean, they have a hookup from, you know, Oracle or SQL Server or Postgres, whatever, into Dynamo. You can make that connection. I think the big choice you want to make there or need to make is like, do I want to just sort of migrate these over as is, or do I want to migrate into a single table design? You can do either one with DMS. And the example I do on the AWS site, it shows how to actually migrate into a single table design using DMS.
It seems to me like the single table is the way to go, and you just have to craft out your indexes, your sort keys, your partition keys, and all your attributes properly, right?
Mm-hmm. Yep.
And secondary indexes you want to put in there.
Yep. I think so. You see some people get hung up on it, and that's because it's different, right? It's definitely a learning curve, so you need to figure that out. The two things I think that are most difficult is like it can be difficult to add new access patterns, especially on old data, right? Now you have to do some migration stuff, which if you have a big SQL database, it's gonna be a hard migration anyway. But you have to do some of that migration. It's a little difficult than just more difficult than writing a SQL script. The second thing I would say is like, there are certain things that it's not great at around flexibility of querying. So if you're used to having lots of different filters, and maybe some of those filters can be optional, that can be difficult to model in DynamoDB. So there's like a specific category of problem that's hard, right? Imagine you had 6 different filters, all of them are optional on sort of a data set. That can be pretty tricky to model in DynamoDB. Now, if your database is a terabyte of data, that's not going to work very well in a relational database either. But you know, if you have 50 gigs of data and some optional filters, you can still do that in a relational database better than Dynamo.
Is Flyway a useful thing to have to do migrations of changes in schema and whatnot?
Flyway? I'm not I mean, probably not. It's not going to be useful in the sort of same way. I mean, basically what you need to do with Dynamo is you're going to need to scan your entire table, identify the items you want to update, and then decorate them accordingly with those items. I think this has been on my sort of backlog to do, is make a project that makes this a lot easier. And I think you can use some basic AWS building blocks to make this happen, to where you only have to set up 2 or 3 things, but I haven't done it yet. But there's nothing like Flyway or other sort of migration tools out there yet.
So the more I get into single table design, it feels like the key is really figuring out when you want to project data around and, you know, denormalize data in ways that like would feel obscene if you were doing this in a traditional relational database. So would love to hear some of your thoughts on that, or if there's been a time where you were going to project, you know, some piece of user metadata on some random document and you thought, this is one step too far, you know, there's a more efficient way to do this. So I'm not just, you know, writing huge amounts of data that are never going to be read in any meaningful way. Yeah, would love to hear your thoughts there.
Yeah, great question. So I tell people that you need to denormalize a little bit with Dynamo, and there's 2 ways to denormalize, and you touched on one of them. So one of them is denormalizing by like having a complex attribute on an item, right? So you might store an array or a map on an item, which you would never do in a relational database, right? You split that into another table and you'd have sort of pointers to it. The second one, like you're talking about, is duplicating data, right? Which is another big sort of no-no in the normalization in the relational world. I think you got to think about the reasons why you want to normalize and not repeat yourself. And the big problem there is like around data integrity, right? If this is a piece of data that's going to be changing, how hard is it going to be for me to change it in all the right places and make sure I have data integrity, or how important is it to get that change, right? So you could think in the case of like an e-commerce store, right? And maybe when a customer makes an order, you copy some information about that user as they are at that time onto that order. Now, maybe you duplicate some of that information, and even if the user later on changes something about them, maybe they change their email address or something else, you know, maybe you don't need to go update those orders because those are all historical orders, and it's fine to have that sort of old data. But if it's data that's, you know, or in a different example, maybe it's data that is totally immutable, right? Maybe if you're putting like one example I show sometimes is like if you have a bookstore and you know information about the author on that book, it's fine to duplicate the author's birth date onto that book item, right? Because that author's birth date is not going to change. So, I mean, I think the things you need to think about there is like, is this data going to change? If it does change, do I need to update it? If it does change and I need to update it, how often is it going to change? And across how many items have I updated it? And if it's going to change daily and I need to go update 100 or 1,000 items every time that changes, like, then I would say don't duplicate. I would say what you want to do there in your application is probably just make multiple requests to handle that, right? Maybe you have sort of a more normalized model. One thing I would say that you can do with single table is it's not a sin to make multiple requests to the database. Try and make them in parallel if you can, right? So rather than having to like go out and fetch a record and then based on the attribute you get on that record, now you need to go out and fetch a different record. If you have to make a sequential call like that, that's where you get into trouble, where you have like this waterfall of calls. But if you have to make 3 parallel requests at the same time and they all come back, it's going to cost you a little bit more if they were all sort of duplicated and together. But I think it'll still be pretty snappy for you.
Cool, thanks.
Andrew had a question in chat. I'll just read the whole thing. So I've read in places that one of the places that a single table design does not show its full potential is when using GraphQL. Could you elaborate a little on that, please? And what other modeling would be used instead? So the one thing, I mean, this goes right into what I was just talking about. The way that GraphQL sort of works, right, is you can send up this you can send up this query that touches a lot of different resources, has this graph of data, but you get into that waterfall problem that I was just talking about, right? Where you have to first fetch the first resource. Once that's resolved, now you need to fetch the nested resource. Once that's resolved, now you need to fetch that next nested resource, and down the chain. Honestly, that's a problem whether you're using DynamoDB and relational databases. So, if you love there are benefits of GraphQL, and I get that. And the reality is, like, if you need to make a waterfall of requests somewhere, and it's just a question of whether you're doing it sort of in your GraphQL implementation or whether you're doing it on the front end, because the front end has to go out and makes a request, wait till it gets something back, and then go make a follow-up request and all that stuff. It's like you have a waterfall somewhere where you sort of going to do that. So yeah, I would say my problems are bigger with GraphQL in general around sort of that waterfall request. The other thing I would say about GraphQL and how it works is, like, often with Dynamo, you're going to model your data more specifically to your access patterns, especially in single table design. With GraphQL, you're sort of not modeling to your access patterns because you're allowing people to sort of specify their own queries for you. So you might not do some of those pre-joining of data to handle, scooping up your organization and all your users in a single request with GraphQL. So because of that, it might be worth it just to sort of model your data in separate tables. Since GraphQL is just going to naturally, do it in a waterfall fashion anyway, you might as well not do some of the single table stuff. So I'd say that's the basics. I've seen a few people do single table in GraphQL. So I think, different people can differ, but that's my 2 cents.
Hey, Alex, have you seen any good tools for trying to figure out asynchronous issues with working with DynamoDB? The issue I'm having right now is that I'm including a bunch of libraries that basically are not playing well with DynamoDB, and trying to figure out where the problem is. And so basically what from my standpoint, I see that I can make it work locally, but whenever I put it in Lambda, it just basically does not complete a promise on a put. And trying to figure out what's the best way to kind of debug that.
Interesting. Are you using, when you talk about promises in a way, are you using JavaScript?
Yes.
Okay. With the SDK, are you using async await?
I'm sorry. Yeah. Yes. Basically in Lambda as well. Mm-hmm. And so in there, basically, it looks like it goes right. Basically, it just goes right by it and doesn't complete. And locally, I'm able to make it work. You know, and like in a Node.js console app, it works fine. But doing it in Lambda, I'm having issues.
The one thing I would say that always trips me up with Node, if you're using async await and you're using the AWS SDK, at the end of your call, you have to do a .promise at the end. Are you doing that?
Yes.
Okay, that would be the big thing for me. I mean, the other one would be, I would say if there weren't any credentials at all, but if you're in a Lambda, there's almost certain to be credentials. And if you don't have the permissions, it's going to reject right away.
Well, this is what's weird. It's like it's really weird. It's like if I do a whole bunch of them in succession, it actually works. So like if I keep on calling the same thing, you know, repeatedly, you know, 40% of them work, and yet some of them don't.
Have you marked your Lambda handler as async?
Yes.
Okay. So like potentially if there's an async, like a missing await or an async invoke, something there. I've seen that happen before where you're sort of not awaiting the promise and then Lambda just completes and finishes before that promise finishes, or maybe even gets fired.
That's where I'm at. I'm just wondering if you have any.
Yeah. I would say TypeScript. I've been using that lately. Like I didn't used to be a TypeScript guy or even a typed language person at all. Been using it lately, and it helps. Like it, you know, it sort of helps point out when you have missing awaits or promise issues or things like that. So
okay.
So maybe give that a shot. Yeah.
Cool.
Yep.
Thanks. Would you be up for? I have a interview tomorrow with AWS tomorrow. For a DynamoDB job, and I wouldn't mind talking to you offline maybe to see if you have any tips for that.
Yeah, sure. I mean, I've never interviewed at AWS, but yeah, hit me up.
All right.
I try to answer pretty quickly, and especially if you're on a time crunch there, I'll try and get you something, you know, tomorrow morning.
And Bill, if that job doesn't work out, you've got IO Associates here to help you with the next opportunity.
We hope it does work out, but just in case, we're your safety net.
I also have, Alex, I have some ideas I would like to run by you based off your book. Your book's great. I really like it. And I've created a utility that basically I'm trying to make it, I have it working locally, but not in the cloud.
Okay.
And I like to run some ideas by you sometime.
Yeah, sure. Shoot me an email. I've been a little busy lately, but I try to respond quickly. So yeah, hit me up.
The main issue is kind of like, I don't know if you have any thoughts about, you know, pre-joining. And so basically working on that.
Yeah. Shoot me an email. Let's talk about that. That'd be great.
Okay, cool. Thanks.
All right. Any other questions for Alex?
The book is available for purchase now, right?
Yep. Been available since I think.
So Alex, any discount codes for the group?
Yeah, sure. If you use the code launch, that's been sort of available forever, and you get $20 off basic, $30 off plus, $50 off premium. Also, hit me up if it's a cost thing. Hit me up. I'll make this work for you.
Well, I'm just thinking Elliot or Sam, maybe let's post a link to that when we announce the recording of the event, and let's just mention the discount code and see if we can help Alex out as payment for his time. Certainly appreciate that.
We'll try and get a few copies sold.
So if we can buy, I reckon if we can buy maybe 2 and put all the names into a random name generator and send it out to the right person, that might be quite fun.
Maybe we'll just make them collector's editions. We'll make sure they're signed copies.
Yes, this is all digital. I can't sign it. I'll have to.
So before we conclude, Elliot or Sam, you want to talk about what we want to do in December?
Yeah, absolutely. So I think December is quite an interesting month for meetups, and so you've had a solid kind of 6 months of tech events. So it's going to be kind of integrating both the AWS and the Azure groups and trying to bring everyone together for a bit more of these meetups, we think they're fun, but just kind of a bit more of relaxed environment. We're going to put on a Christmas quiz and details to be sorted out in terms of how we're going to sort out teams or put all the questions together. But
Yeah,
just
we want to
kinda
raffle off some prizes, get some nice sponsorships going from some
yeah,
tech
absolutely.
companies,
So we'll we've got a month or so to kind of generate a few things and put some incentives in there for your participation and reward for supporting the group. So yeah, keep an eye on the groups. It will be a cross group event, and yeah, we're looking forward to kind of bringing that to you all.
You're going to have Azure guys and AWS guys in this.
Yeah,
I know, it's
out.
crazy.
Rivalry.
Hey, I'm both. It's possible. You can be non-binary, I promise you.
It's gonna be savage. I'm looking forward to it.
AWS, this is your Christmas quiz.
Let's hope Azure doesn't have a global outage again in the middle of that.
All right. Well, thanks, Alex, again for the presentation. That was great. Thanks, everyone, for their participation. Thanks, IO Associates, for your continued involvement and sponsorship. And hope everyone has a great evening and a great holiday season.
Enjoy your evenings, guys. Pleasure as always.
Thanks, Alex.
Thanks a lot,
Thank
guys.
you all.
Speak
Cheers,
soon.
guys. That was great.
Thanks so much.
Take care.
See you guys.
Yeah.
Thank you, guys.